Good day. Welcome to another series of the Whiteboard series. Today I'm going to talk about light. Now for this Whiteboard series, I'm going to focus on the key concepts of light, ignoring anything that is additional. So please go and read up on your own if you need additional details. Now, first things first, what we need to understand is that light is a form of energy. This is something that is very important. All right. And we need it to see things around us. So if you realize, right, when you walk into a dark room, you cannot see anything because light is not entering your eye. There is no light at all. However, the minute you turn on the switch for your light, you'll be able to see things, because what actually happens is that the light rays from a light source has hit an object in your room, and the light will get reflected from the object into your eye, enabling you to see it. Now, we need to understand that our main light source is actually the sun. Alright, this is actually our main source of light. So before I continue, let me just talk briefly about what is a source of light. A source of light is basically something that gives off light. Okay, so I'm just going to write it here. Alright, something that gives us light. So there are basically two types of sources of light. One is natural and one is man-made or artificial. So what is considered natural? Things that exist as it is naturally from Mother Nature, like your sun or even your fireflies. So at night you're able to see fireflies not because someone installed an LED light onto the insect, but because within that insect there is actually this chemical reaction that is going on that actually enables the fireflies to make their own source of light. And the sun is important to us because this light energy that it provides also enable your plants to photosynthesize, making its own food. So when you think about it, if plants are not able to make their own food, eventually all living things would die. Because when you think about it, who eats the plants? Us humans, right? And besides us humans, the animals that we eat, for example, chicken or even our cow, they actually feed on these plants, and then we feed on them in return. So if plants were not able to make food, then obviously we will all die. So we need to understand that light is not a matter because it does not have any mass or volume. So think about it. In the previous video, I talked about matter, whereby matter, in order to define something that is a matter, it must have mass and volume, these two. So like I say, objects that gives off light are known as sources of light. So main source of light would be our sun. So these are some natural sources of light: lightning, firefly, volcanic lava. And of course, like I mentioned earlier, there's also your artificial light, which is your neon signboards, your television, your torch, and your lamp. So your moon is not a source of light. You basically can see the moon because what happens is that your sun, which is over here, is your source of light. And what happens is that it will actually give off light, and then it will hit the surface of the moon, and then it will reflect. Now the reason why we can see the moon is because this light ray actually enters into our eyes. So once again, it's from the sun, hits the moon, gets reflected into our eyes, and that's how we actually see the moon. And this phenomenon of having the rays bounce off an object reflecting to our eyes happens for most of the items that we're able to see. Okay, so yeah, water is the same thing. We're able to see that the water there is because, once again, light gets bounced off the water and into our eyes. Okay, mirror as well. So these are not sources of light. Instead, they are reflecting light from other sources. So there are three things that can happen to the light rays when it falls on an object. So the first one is that it can be reflected. Reflected means that it bounces off the surface. So this blue color line here, it actually represents the surface of any object. So when it gets reflected and it goes into our eyes, okay, that's where we're able to see the object. Next, it gets absorbed. Alright, so when it gets absorbed, it goes into the object. It would not bounce off. Alright, so a good example would be the color black on a very rough surface. So surfaces that are dull in color and very rough, they absorb light very well. So they appear to be very dull. That's because light is not being reflected off them when we take a look at them, as opposed to something like maybe it's very like a holographic item, really shiny, like a compact disc. All right, then you see, wow, it's very, very shiny, like some hologram. Okay, sorry, holographic I meant. Now, the last thing that can happen is it can also pass through an object. This happens when, for example, the object is transparent, like your glass or your clear plastic. So what you see over here, all right, is something like a ray diagram. So a ray diagram basically shows you where does the light come from and where is it going. Now this is very important. A lot of students don't understand how to draw a proper ray diagram. So I'm going to talk about this. Number one, the ray diagram needs to come from a light source. So in this case, the light source is actually your lamp over here. Okay, so I'm going to put it as 1. So as you can see, there is actually a line. I'm going to try and draw it from here going to the book. And then after that, the line goes into the person's eye. Now there's a few things to note. One, it is very important for you to use a ruler. I know I'm not drawing a straight line. That's because I don't have a ruler with me now. But please use a ruler to draw a straight line. Next, you need to actually add an arrow for each line that you draw. And how do you do that? It's very simple. You just do a V shape like this, okay, to show me that the light ray is coming from the lamp to the book. So the book is number 2. And then from the book, it gets bounced off and reflected into the person's eye. So you need to draw another arrow. So remember, it's 1 arrow per line. Now the next thing is, when at the object, you need to realize that the 2 rays needs to join. Sometimes students tend to do something like this. They would draw the light ray going to the book and exiting from another part of the book like this. Now you notice that these 2 lines here, I'm going to use a different color, are not joined together. So that's the wrong way of actually drawing a light ray. Alright? Okay, so these are more examples of light rays. Okay, this is correct. This is not so correct. Okay, this is because the light rays are not joined together. Alright? So basically, although most objects around us are not sources of light, we can still see them because the light that falls on them then get reflected into our eyes. So it's also important to note that your light actually travels in a straight line. Okay, it cannot bend. So for example, if I have a wall here and my eyes are here, all right, and I have a light shining here, my light source is here. Now it's important to note that the light cannot go around the wall and then go into my eyes. It doesn't do that. All right. So instead, what happens is that when this happens, you will realize that when it hits the wall, the light cannot go through the wall if the wall is an opaque wall. All right. So when a light ray hits an opaque object, some light is absorbed and the rest is reflected off, like that. Now, however, when you hit a transparent object, most light can pass through. And when it hits a translucent object, some light can pass through, and the rest is reflected off. So different materials allow different amount of light to pass through them. Okay. So what happens is that these materials allow most light to pass through. A faint shadow can still be formed. So things like your transparent object. Now these are known as translucent. They only allow some light to pass through. Once again, you will form a faint shadow. That means a shadow that's not very dark, same as transparent object. And we cannot see through them clearly, but we know that they are there and they allow some light to pass through. So some applications of this kind of materials will include your shower screen that you use in your bathroom, all right, where you want light to enter, but you don't want people to see what you are doing in the bathroom. Okay, so these are called translucent objects. So then the last type of object or material is known as the opaque objects. Now for opaque objects, right, they do not allow any light to pass through, absolutely zero. All right, a dark shadow is formed. And we cannot see through these objects at all, absolutely. So shadows are formed when the path of light is partially or completely blocked. What do I mean by that? For example, if let's just say I have an object over here, okay, this is going to be translucent. Now, if it's translucent, the rays from my sun, some of it will be able to pass through. However, some of it will be reflected. Now, because some of it is being blocked, some of the rays, I will get a very faint shadow over here. Just a very faint one. All right. If let's just say I have something that is solid, my light rays, when I hit it, none of the rays is allowed to pass through. It will bounce off or be absorbed. Then my shadow on the other side will be solid. It will be very dark and solid. Now the shadow always forms on the opposite side of the light source. What do I mean by that? So for example, in this case, my sun is on this side. This is my light source. You realize that my shadow is on this side. And this side is actually the opposite side of my object. So that's what we're saying. Now the shape of shadow changes when the light source shines at different parts of the object, as light travels in a straight line. Okay, so what do we mean by that? So as you can see, what is happening here is you have a tin can in this slide. Now the shadow is actually circular because you face the circular part of the tin can facing the light source. So the shadow form would actually be circular. However, if you were to stand the tin can upright like this, you realize that the shape has actually changed from a circular, okay, into a more rectangular form. So in exams, you actually need to try and visualize what kind of shape it will be formed. Now, this is very, very important. I want to stress this very common question to be asking. Now, the size of the shadow that is being formed on a screen depends on the distance between the light source and the object. Okay, now the next few slides is going to be very, very complicated. All right, so what I'm going to do is I'm just going to fast forward this and I'm going to explain to you using a blank slide. Now, there are three things that you need to know. Okay, so whenever they are trying to form a shadow on the screen, there is the object, there is also the light source, and the screen. All right, now what you need to do is that you need to understand that the distance between all these three things affect the shadow size. So what do I mean by that? Now, for the very first one, I'm going to actually draw you a light source. This is my torch. And then I have my object over here. I'm going to use like a block. And finally, my screen at the back. So when I switch on the light, a shadow is going to be formed. Now, this shadow, okay, the size can change according to the position of the items. Now, the first one is the distance between your light source and your object. And the second distance that you need to take note of, which I'm going to call it D2, is the distance between the object and your screen. So I'm going to label these items so that you know this is your light source, object, and your screen. Alright, so the first thing to note is that, okay, when D1 decreases, shadow size or shadow height increases. Okay, so this is D1 that I'm talking about here. So as either the object move closer to the light or the light move closer to the object, your shadow size will actually increase. Alright, the next rule to remember is when D2 decreases, shadow size or shadow height decreases as well. So what do I mean? So you take a look at D2 is actually the distance between your object and your screen. So if you were to either bring your screen, okay, closer to your object or your object closer to your screen, it will result in a shadow that is actually shorter in height. So the height decreases. So let's take a moment to think. If I want to actually increase the size by moving the screen, I should actually push the screen further away from the object. So as I increase the distance of D2, whereby my screen is now further away from the object, the height of my shadow would actually increase. All right, so this is something that you really need to know. It is a common question that will always be tested. Okay, so the rest of the slide is just going to explain what actually happens. They are all in your notes. You can refer to your notes. So therefore, I'm not going to talk much about it. Right, so this is to illustrate to you. Can you see? This is the closest, shortest distance, shorter, and then the largest distance. So as you can see, as the object moves further away, all right, remember D1 increases. What happens? Your shadow becomes smaller. Okay, that's what it's trying to say. For the next part of the lesson, I'm going to talk a little bit about how the sun actually creates shadows. All right. So the important thing is to note that most objects block sunlight from the sun, and their shadows are cast on the opposite side of the sun. So remember earlier on, we actually know that the sun is actually a form of light source, right? Okay, so that is something that we need to take note of. And earlier on, we also said that shadows are always cast on the opposite side of the light source. So what does that mean? So if your light source is here, your object is here, then your shadow will be on the opposite side, okay, to your sun, which is over this side. That's what it means by that, okay? So what we also need to know is that as the day progresses, the position of your sun changes. Okay, the position of your shadow and the size also changes, because when you think about it, I guess it only makes sense because you are actually changing the light source position. So remember, in the previous slides, we were talking about how the position of your light source in relation with your objects, when the distance increases or decreases, it can change the size. So this is the same. The only difference in this case is that we're looking at a, a natural phenomenon. Okay, so we have to memorize that shadows of objects at noon are shorter than those cast in the morning or in the evening. Now, this is very important because a lot of questions, they would actually give you this compass telling you that, oh, this is actually your north, all right, and then they ask you how the shadow would be formed. So you need to actually recognize that if this is the north, then the opposite side of north will be south, and then after that, on the right hand side is always the east, and the left hand side is the west. Now, why is this important? Because you need to determine the position. So for example, if the question tells you, oh, in the morning, so we all know that, if you didn't know, I'm telling you now, that the sun rises from the east. So the sun will be starting off from this side in the morning. So if the question goes, oh, it's in the morning, how will the shadow look like? So you have to remember that the sun is from the east side on the right side, and the shadow will actually be cast this side, and it's pretty long. Okay, why do I know it's pretty long? Because it states right here that shadows of object in the noon are shorter than those cast in the morning or in the evening. So if it's morning, you need it to be long. And then after that, if they tell you that, oh, the sun is actually during noontime at 1 p.m. So the sun will be here. Okay, and your shadow should actually be right at the top, and it should be the shortest. And when they say, oh, in the evening, so in the evening, we know that the sun sets in the west. So your sun would be in this position instead, and the opposite side would be here. And you need to draw your shadow longer because it's already told to us that shadows in the evening and in the morning are actually longer than those of the noon. Okay, so this slide just goes on to illustrate what I've just said. Now, light reflection in a periscope. Basically, a periscope, right? It's this tube-like instrument that helps people see things that are maybe they are too short and they are not able to see. So what happens is that it makes use of the fact that light travels in a straight line. So hence, you see that they are all straight lines over here. All right. So what happens is that it uses the mirror and it reflects it off, okay, into our eyes. Now, the one thing I want to caution is that make sure you realize that when you are determining the direction of your ray, the ray always comes from the object that you want to see. So for example, you're looking at this band. The arrow should be from the band to the mirror, and then after going to the next mirror because it gets reflected off, and then finally into your eye. That's how it's supposed to be. All right, never the other way around. A common misconception of students is that they tend to draw the light rays the other way around, which is wrong. Now, as light travels in a straight line, a periscope can be used to see objects which otherwise would be difficult to see. The mirrors inside a periscope reflect the light into our eyes. All right. Okay, so that's about it. Now, I just want to summarize what's really key important. Now, remember that light can pass through certain materials. Now, there are three types of materials that you need to take note of. All right, the first type of material would be your transparent materials. Now, transparent materials allows almost light to pass through. Okay, that includes glass, clear plastic. And then you have translucent that allows some light to pass through. That will include your frosted glass or even a very thin sheet of paper. Last but not least, you have your opaque materials that does not allow any light to pass through. All right. Also take note that it's very important that you memorize the different positions of your light source, object, and then your screen. So if you're unsure, please go back to the video to try and understand about distance 1 and distance 2. Okay, now in exam, obviously you cannot say, oh, sorry, just let me go back to that slide. Okay, I'm sorry, I can't do that, but the key idea is you have to understand that you cannot say distance 1, distance 2 in exam because there's no such thing. The reason why I put D1 and D2 there is to help you better understand. So for example, if you want to talk about how your object increases in size when D1 decreases, you have to say that as the distance between the object as the distance between the object and the light source decreases, the shadow form on the screen will increase. Or you can say as the object is brought closer to the light source, the shadow formed on the screen will increase. Please do not use D1 and D2. All right, I just want to caution you on that. Please go and practice. All right, so that's all for this video on light.